In this video, we're going to be covering another interview question. This is question number 127 of Leetcode. It's called the word letter. Uh, there are many different versions of this question. This is, I would consider, towards like this is like the very generic one in which we have been given the begin word and the end word, and then we just need to tell how many iterations did it take us from going from the begin word to the end word. uh, how many iterations were there, right? The other iterations of the questions could be sometimes they are in the form of graph instead of the strings. Sometimes we need to return the iterations itself instead of just returning the total number of transformations. So yeah, so for this one, the begin word, we're gonna say that the begin is hit, the end is cog, right? And we have a dictionary here. One thing we definitely want to do and we will be doing is like converting the word list, which is a string of list of string, to dictionary, sorry, to a set. And the reason for that is like uh, because if we keep it list of strings, it's gonna take us linear time in order to for us to find out if the word which we are looking for is in that word list or not. So that's the first thing, that the word list is going to get converted to a dictionary, to a set, right? So you can just say that we're gonna make this thing the name of the variable is gonna be a dictionary. We don't have dictionaries in the Java, so we're just gonna call it dict. So the algorithm we're gonna be using the breadth first search, right? We're gonna make use of two sets here. One is the is visited, which is gonna start with the begin word, which is hit, and then the other one, sorry, this is gonna be the only set. Basically, makes helps us not to get into an infinite loop where if we have seen something and we are tweaking the word in order to get to the next word, we don't want to get into an infinite loop. So if we have already processed it, we don't want to process it again. That's why we're going to be using this set. The other one is going to be a queue, and we're going to again start it with the start word, the begin word. Okay, that being said, we're gonna, because it's a breadth first search, we definitely have a queue, and the way it goes is like you fill the queue with the one word, and then you every single time you say that while the queue is not empty, you take the word out of the queue and process it, and if the results are of your choice or whatever you want to do with it, you put the results back into the queue. So the first thing we want to do is to remove that word, and that word is going to become equal to current, and we're going to start processing this current word with index, and we're going to, wherever index I is, we want to change it from A to Z, and this is because of the limitations here there, where it says that all the words are gonna be only lowercase English letters. That's the reason we're just gonna change our I from A to Z. So the words are gonna become AIT, BIT, CIT, so on so forth up to ZIT. And we're gonna keep looking for all these transformations, that whether or not they are in the dictionary like this one, or the word list. And yeah, if that is in there and we have not processed it, if we have not visited it, we're gonna put it inside the queue, right? And that would be it. and every single time once, and we're gonna be stopping whenever we find the end word. So this is the breadth first search, because we are actually tweaking them in the same loop. We can actually go to multiple words and process them and put them in the queue, because you can process one word by taking one word out of the queue, or the next time we're going to be processing maybe three words. So let's say there was AIT, BIT, and CIT. All of them were present in there in the dictionary. So the next time we're going to be processing three of them at the same time, while saying that we are in the same processing step. So in that step, we're just going to be returning two. Maybe it will become more clear when I will write the code here. Yeah. In terms of the complexity, let me write the code and then we're going to be talking about the complexity here. So first thing we said that we do not like the word list to be the list of string, because it's going to make the, in order for us to find out that the word is in there or not, it's going to take us linear time. We want to convert it to a set. So for that I will say set of string, let's call it dictionary, is equal to new hash set, right? And then put it into, I've put everything from the word list inside the dictionary. Yes. So now we can actually find out if a word is available in their dictionary in O of 1. Okay. Now we talked about is visited, right? Is visited. So we have the is visited, right? And then also talked about the queue. That's how we define the queue in Java. There can be linked list or there can be array of list. Okay. Okay, int count is equal to 1. We're gonna start with count equals to 1, and the reason for that is that again we can have a zero count, but that we're gonna be covering into another one. But if we have an answer, it cannot be less than 0, right? If the basically if we can get to that place, from the begin word to the end word, uh, if we can, if we have a process of getting there, the minimum it can be is count 1. Okay, again we said we're gonna start with adding the start word, oh the sorry begin word to queue, and is visited dot add begin word. Okay, that would be it. Now we're gonna write down the structure, the main structure of the BFS. We always check whether queue is while the queue is not empty. We're gonna keep processing it, right? And yeah, if we come out of this queue, like if we come out of this, it becomes empty and we haven't returned anything, and we are not done returning anything. That means there is no way you can go from begin word to the end word. That means we're just going to be returning 0. So while we're processing it, we're going to say, as I said, we can process one word at a time or multiple words at a time in the same count, this count. So we're gonna know that by checking the size of the queue, right? Then for those many words which we want to process in one count, int I equals to 0, I is less than and I plus plus. Okay, now again the current is gonna be equal to, we wanna remove that q, right? So that is our current. How we're gonna be processing the current? We're gonna take the length of the current and try to change every single word of that current string from A to Z. So for that we'll say I and j is equal to 0, j is less than current dot length j plus plus. Okay, in order to, so this is basically uh, our j, this is gonna be our j looking at that one, right? So the j is there and we are looking at every character. In order to change the character, because we're gonna just say that q is equal to j 0 and j, sorry, we're gonna say character c is equal, starts from a and then goes up to less than equal to z, c plus plus, and we wanna create that new string, basically saying that the current dot substring from 0 to j, we want to keep that. Then we want to add our new character, and then we want to take one less character from the old string. So for that, substring j plus 1. Okay, so now we have the new character, we changed it and we have the new character. We want to check if the dictionary contains it or not, and that's the reason we changed our list of string to a set, that we can actually check it right away. And is visited should not also have that, meaning we should not have processed it before. Okay, if that is the case, right? So the first thing is that this word is gonna go into uh, uh, the queue. What else? Also, we wanna say that, and this we wanna make sure that we don't process it next time. But the main thing is that if this new word, right, is equal to the end word, that means we found the solution. All we have to do is to return the count plus 1. Where do we want to increment the counter? That would be over here. When we are processed whatever is the size of the queue, when we are done processing that, that's where we want to increment the count. Okay, let's just talk about the complexity for a second here. So in terms of the space complexity, I am using multiple sets here, depending on the size of the word list, right? First of all, I needed that. The queue can have only as many words as there are words in the word list, again, so that's linear. So wherever, in any case, in the worst case scenario, whatever, the space complexity is gonna stay linear. If we have n number, n is the length of the list of words, that's gonna be O of n, our space complexity. So in terms of time complexity, right, we are up to this point, we are linear, we are putting it into the dictionary. Okay, we took that into the queue, and then we are processing it. But this is hard coded numbers. We are in this loop we are actually changing everything, and uh, we are changing every character in it, and we're changing every character in it. But this is hard coded because we can only go from A to Z, so that wouldn't so basically, and this loop is like, okay, you got one word, uh, you are processing single characters of that, because this is the current dot length, and you every single time you want to be creating the new one. But if we if this is O of n, right, if this is n number of strings in the word list, the time complexity is still linear. If we just consider it as if n is the number of words, right? So the O of n, it's gonna be time complexity is gonna be O of n, where n is the number of words in the list. If we go into the characters, like how many like in terms of characters, like then it's gonna be we are processing every single character, so it's gonna become um, yeah. So although we have multiple for loops here, so we can have n here, but for this is like this one is going, so we took one string, right, and every one of them, yeah, because yep. So let's think of it as like, over here we are just thinking that, okay, if this is the total number of, where is it, over here we have n number of words here, we are taking one word at a time, so the time complexity is gonna stay linear, right? But what if this word is very long word, right? Let's say it is millions of characters long, then yes, that would be the total number of characters would be n multiplied by m, which is the longest character. uh, so if the n is the number of dictionary words and m is the longest uh, longest string, right? So yes, worst case scenario can be n cross m. That is true. But remember, this m is the number of characters inside that word. Let's just run it, and it works. And yep, those were the things I wanted to cover. Thanks for watching.